Okay, so we know that often in case 3 for partial fractions, we're going to end up with integrals like this. Okay, and we want to know what is the rule for how the antiderivative works out. It always works out in the same way, and it's going to be based off of this a term right here. So it looks very much like arctan. It is going to give us a variation of arctan, but what is it and how do we get it? So here, first off, this is what we're going to end up with. The antiderivative of 1 over x squared plus a squared will always be 1 over a arctan of x over a. Okay, and that's what we're going to use. That's going to be our general rule, but we're going to take a moment to figure out why it works. And then once we know why it works, every time we come across an integral like this, we can just use this antiderivative. So if I see this integral, 1 over x squared plus a squared, if I wanted to find the antiderivative, I can recognize x squared plus a squared from when we did trig sub. And I know that in that scenario, I'm going to be doing the trig sub x equal to a tan theta. That means that dx will be equal to a times secant squared theta d theta. And we're also going to want to simplify x squared plus a squared, which, if x is a tan theta, gives you a squared tan squared theta plus a squared. Factor the a squared out, the same as we did in any of the other trig subs. That leaves us with tan squared theta plus 1, which is perfectly equal to secant squared, and that's why we did this trig sub. So x squared plus a squared gives us a squared secant squared theta. We'll plug that in over here, and dx is a secant squared theta. So this is going to give us, in the numerator we have a secant squared theta d theta. In the denominator, we know we end up with a squared secant squared theta. And as we saw in the last video, we know this is always going to simplify. We have the secant squareds are going to cancel each other out. This a, one of those is going to cancel with one of the a's in the denominator. And we end up with 1 over a integral of just 1, because secant squared over secant squared is just 1. We really have here just d theta. So fine, what's the antiderivative here of 1? That's going to give us just theta. And then the last thing to do is always going to be to just go back from theta to x. So what is theta equal to in terms of x? Well, we go back to our original trig sub for that. If x is equal to a tan theta, let's take it over here. If x is equal to a tan theta, that means that tan theta is equal to x divided by a. So what is theta equal to? Well, here we know that arctan is going to be the inverse of tan, so theta will be equal to arctan of x over a. And that's what we're going to sub in right here. So we end up getting, for our final answer, 1 over a arctan x over a. Put in the plus c, and that is exactly what we wanted. And that is why the antiderivative of 1 over x squared plus a squared is always 1 over a arctan x over a plus c. And from now on, we'll be using that rule every time we run into these irreducible quadratics from case 3.